Hello everyone and welcome to our project presentation. The title of this project is Room Temperature Programming Optimization, and the goal of this project was to identify the optimal temperature settings that will maximize the energy savings. We will briefly describe you who we are and the company. We will proceed with the project and data overview, following the EDA and clustering, and we will conclude with the results and the next steps.
Hello everyone, my name is Dimitris Tomaras. I studied mechanical engineering in the National Technical University of Athens and now I work as a data analyst in the energy sector.
And I'm Dimitris Bakoyannis. I'm a naval architect. The last few years I work as an R&D project manager, and my goal is to transition in data science.
Tiko is an innovative company offering many uh, energy products, one of which is the RTP, Room Temperature Programming. This is a mobile or web-based app that allows you to set the desired temperature in the house, room by room, and also monitor the consumption. The goal in using the Tico app is to achieve energy savings up to 20%.
The end goal of this project was to optimize the user's temperature settings. The first step was to extract the necessary data from the company's database using SQL. The next step was to clean our data, do the necessary grouping and aggregation, and come up with our final dataset. Then we have to understand our data better, dive deeper in the physical background of our features, and decide which of them are relevant to our project. Finally, we used machine learning algorithms and rule-based functions to cluster our users.
The first part of the project, ETL, lasted at least half of the available time, and the goal was to create some tabular data about the users. For that, we downloaded 13 tables from the company's databases that include 48,000 devices, direct electric heaters, and the trickiest part was to homogenize all of this data as the tables had different time granulations. We also used one API to download the elevation data for France, and the time window for the data is the last winter, October 22 to May 23. Before we deep dive into our data, we must stay and understand that there were four different categories of those. The first two, spatial and house size data, are the data that cannot be changed. And on the contrary, behavioral data are those data that can be amended by the user thanks to TICO application. All of these affect the savings, which is the goal while using TICO app.
Now, starting from the spatial data, they are mainly related to the location of our devices. While size of the house, we created two new features, number of heaters per house, and also normalized par, which represents the heater size. On your screen, you see a map representation of our users in France per region. Following, we have the behavioral data. Here, the main feature is diagnostic state, and we have two main schedule categories. The first one is a flat, where the user keeps a fixed temperature, and the second one is a functional, where the user changes the temperature throughout the day. Another feature we introduced is number of daily steps per device, which actually represents how many times per day the user will change the temperature. As targets, we have total savings and savings to power. Here we have a time series plot. The gray line is actually the average outside temperature, and the red one is the average savings. What we want you to observe is that when we have the lowest temperature, we actually have the highest savings and vice versa. Now, let's see some cool facts about our data. We have almost 5 devices per house. 60% of our users prefer the flat temperature scheduling, and the best window to maximize your savings is on the coldest days.
As stated, energy savings is the goal while using TICO app, so this should be the driving feature for our analysis too. When we initially analyzed the average daily savings per home, as calculated by thermodynamical model and stored in companies' databases, we noticed a heavy correlation with the size of its home. To solve this issue, we introduced the ratio of average daily savings divided by the total installed heating capacity of each home, and we call that savings to power ratio, and it is expressed in hours. So if we see the example in our screens, the two homes saved before, thank you. The two homes save the same amount of energy, but the first home has double savings to power ratio as it has half of the installed heating capacity. What we managed to do with this new feature are shown in the highlighted part of this correlation matrix. We decorrelate the energy saving from the house size. We achieved having a qualitative expression of the energy savings, making all the house comparable to each other, regardless of the house size. Last but not least, savings to power ratio expressed in units of hours has also a physical meaning. It depicts how many hours a user managed to turn off the heaters daily, thanks to tiko app, while maintaining the desired house temperature.
The next step was to use different machine learning algorithms to cluster our users. Here are the results of the K-means algorithm. Cluster 2 are the yellow points and they represent users that they have high savings and they prefer functional scheduling. Cluster 1 are the pink points and it's characterized by higher elevation and outside temperature. As we can see on the map, the users are mainly located in the French Riviera and the region around the city of Lyon, while cluster 0 are the brown points and they represent flat scheduling users that they have low to average savings. As we can see, the most significant features for this example are actually related to the scheduling, while savings are not so important. So we wanted to investigate further how important is the scheduling and also do a segmentation based purely on savings. Here we have our savings to power feature, and what we see is that it follows it is an exponential curve. So we decided to move with three different classes, low, average, and high savings class. Here are the results of this example, and as we can see again, functional scheduling is the most important feature. But in contrast to the machine learning approach, in this case, location is not actually related to the saving segmentation.
After the above analysis, it was made clear that we should understand how the behavioral data of each user affect the savings that they achieve. So we plotted every histogram and perplot of the behavioral features, highlighting our three savings clusters. Whatever hint the graph showed then was tested with statistical tests, and we concluded to the optimal settings for energy savings, which are to vary the desired temperature profile throughout the day, at least with 2 steps per day, and keeping those temperature changes, those steps, lower than 4 degrees Celsius.
As we understood from today's presentation, to keep functional scheduling is very important if you want to maximize your savings. One way to increase the user engagement in the tiko app is by implementing monthly reminders to the low-saving users of how much they could save if they prefer the functional scheduling. One example of this personalized notification is, "Hey Dimitris, functional scheduling with this amount of steps in the last month could have saved you this amount of energy." These values will actually derive from a high-saving user that has a similar profile.
Our next steps. First of all, we would like to cross-check this savings feature that we have, and it's based in a thermodynamical model with actual measurable data from our devices, like the actual power consumption compared to the area of the house and maybe some energy efficiency of the house. Then we can start splitting data to monthly and weekly aggregation instead of an aggregation per the whole window for the whole winter per house. That will give us many more data to analyze. After we conclude which are the top performance, we can deep dive into their time series of desired temperatures and try to identify patterns that make them achieve the best savings in energy.
From the business aspect, our first proposal is to create custom tiko app recommendations. The second one to create a regression model using the non-behavioral factors to predict savings. I remind you that non-behavioral factors are the data related to the location of the device and the size of the house. And thirdly, to set a threshold for energy savings and create custom offers and rewards for the users that achieve these goals. Special thanks to Tiko and Big Blue Data Academy for this opportunity. Thank you all for your time. Do you have any questions? Σας ευχαριστούμε πάρα πολύ όλους για τον χρόνο σας.
Thank you very much. Σας ευχαριστούμε.
Dimitris and Dimitris, thank you so much for this lovely presentation and the excellent work you have done the past 5 weeks. Okay, I have one question myself. What was the most difficult part in your process, especially in the data handling? Because you have 0.5 gigabytes of user data, and how long it took to process this and understand this amount of data?
Well, I think, as Dimitri said, the most difficult part was actually to homogenize this data set, as we have different time granulations. So we actually have to try to have a master table of the devices at first, and then to proceed to the user data. So I think that was, for me, the most difficult part. And actually, this, I think, lasted more than the half of our project. I think around 80%. It's the 80-20 about data cleaning, understanding, and 20 to...
Exactly. Thank you for the question, Dimitris. Indeed, the most tricky part was to understand the data that we have in hand. I would say that now we started the project by creating a pipeline, let's say, and an understanding on how we can handle the next data. Before, we were just downloading, not knowing what to do with all of this data. Now that we have categorized them and we have defined some standard methods in order to analyze them, we can start adding new data, creating new features by the available data in the databases, and start producing real value for the company.
Yeah, I think this is the most amazing part in your project, that right now actually you open the doors to do, I mean, for the company to start building something meaningful on top. And I have really high hopes and cross fingers that this will, let's say, escalate to a different level really, really fast. And I really wish you all the best. And I also like to tell you once again that congratulations for your excellent work.
Thank you.
Thank you very much.
Congrats, guys.